Over the weekend, a number of news outlets reported on a publication which documented a study design to look at the active drug in a drug called ecstasy to treat social anxiety and autism. Through the weekend, I've been patiently waiting for at least one of these news outlets to report that, number one, there's no known safe dose for this drug. Two, the drug in ecstasy is called MDMA, and it's neurotoxic even after just one dose. And three, regrowth of neurons after a toxic event is erratic, with short and irregularly shaped neurons that doesn't ever really completely regrow. Given that people with autism have brain cells that are already somewhat misshapen, some of these neurons go to the wrong areas of the brain, I'd assume that someone would catch this and say, this doesn't really seem like a good idea. Unfortunately, the media reports didn't pick up on these scientific facts, and were really caught up in the debate over legalization or medicinal use of MDMA rather than the viability of the potential to treat social anxiety. While overall I'm enthusiastic about the use of these non-conventional medications to treat adults with autism, I have to feel like I have to put the brakes on this. This drug is dangerous. This isn't really a treatise about club drugs or illegal drugs, but about this drug in particular. As I mentioned in my blog this week, MDMA is a potent neurotoxin. It kills serotonergic neurons in controlled studies, as well as been shown to have a toxic effect on human brain cells. It's also toxic to cardiac and liver tissues, and while the authors maintain that the drug would be given in a soothed, controlled environment rather than a club, why risk it? And even if it does work for social anxiety, this is a compound the autism community wants to stand behind. Shouldn't research efforts be put towards those that do not kill brain cells? While the publication was mostly ignored by the scientific community, the mainstream media picked up on it 3 months after it was published. I have no idea why. Not one toxicologist or pharmacologist or anyone that works with autism was asked to provide perspective. There was absolutely no data in this article, just an outline of the study design, which the authors claim has been IRB approved. While some news stories have said new data or evidence, there really is no evidence here. So I don't want to give this story any more traction, so I'm going to leave it at that. So on to real science. Another science story that is notable but not directly related to autism yet is a finding published in the journal Nature about the presence of a direct biological link between the brain and the immune system. I'm posting an image on this page of what scientists used to think the relationship was and what we know now. Previously, it was thought that somehow the brain was protected against immune cells which circulate throughout the body. The actual immune cells could not pass into the brain, but the brain could read the immune status of the body through certain chemicals called cytokines, which are activated by the immune system. So it was kind of an indirect link. You've heard about different cytokines being increased or decreased in people with autism. So the researchers at the University of Virginia developed a new technique where they could dissect the meninges, or the layers surrounding the brain of a mouse, and put it on a slide and look and find areas where there might be a direct connection. This hadn't been able to be done before. Using a mouse model, they were able to show the presence of structures that directly connects the brain to the immune system. Believe it or not, before this, doctors did not know it existed, but it did exist for every other organ in the body. So what does this mean for autism? Because there are a number of links between autism symptoms and immune functioning, at the very least, established genetic models of autism should be studying the meninges, or the layer of tissue that protects the brain, and these vessels which connect to the immune system to see how it works. While nobody has actually looked at the presence of these vesicles in human brain tissue before, hopefully now they can and they will. This finding will certainly change the textbooks about the link between the brain and the immune system, and it does have implications for autism. So finally, just one more thing, which I'll post on our Facebook page later this week. Earlier this year, ASF compared what ASF grantees were doing 4 years after they received their ASF fellowships, compared to those who applied but were not funded. We tracked down everyone electronically and were helped by amazing ASF fellows who updated us long after their grants were finished. Casey Allison and I found that both groups, the unfunded and unfunded, they were publishing, they were getting additional grants. And both groups were getting postdocs or had postdoc level research positions. However, ASF awardees were more likely to stay in the field of autism research compared to those that were not funded. This was the rule, but there were exceptions. Most of the applicants, regardless of whether or not they were funded, went on to do amazing things in science. But the ASF fellowship seemed to push people to stay into autism research. There was only 1 year of data at the time to report, and we presented a poster at IMFAR. The amazing intern this summer, Esther Ju, is tracking down more applicants from later grant years to see if this effect was consistent across both funding years and pre- and postdoctoral awards. So stay tuned. Thanks again for listening, and talk to you all next week.